Hello everyone, welcome to my channel. I'm going to start a series of videos on mapping of MT103 to pacs.008. I will record videos explaining the mapping block by block. There are 5 blocks as you know in MT format, hence there will be 5 videos in the series. In today's video, we are going to understand mapping of block 1 of a SWIFT MT103 message to ISO 2002 to pacs.008 message. So as we understand the mapping of MT103 to pacs.008, it will be easier for us to interpret the other mappings of other MT to ISO 20022 messages. Now, this is mapping of 103 block 1 to pacs.008 is a header mapping exercise and not a payment field mapping exercise. Payment related details are present mainly in block 3 and block 4 of the MT103 and are mapped into the document section of pacs.008. Block 1 primarily contains the technical information used by the SWIFT FIN network to identify and process the message. On the screen, we can see this block 1 example. In this session, we will break this value into its individual components and understand which parts have a meaningful relationship with ISO 20022 format. Okay, let's begin by understanding the definition of block 1 and the structure of block 1 in MT103 context. So block 1 of MT103 or any MT format is called a basic header block. It is used by the SWIFT FIN network to identify the sending technical address and session and the sequence. Block 1 does not carry the debtor, creditor, amount, currency, charges, or remittance information. Now think of block 1 as an envelope level and not the payment instruction itself. Let us take this particular example. The opening, which is 1, this number basically tells us that this is a block 1 of the SWIFT message. The remaining value follows a fixed structure. It is divided into 5 components. F followed by this 2-digit number, followed by this character, followed by this 1, 2, 3, 4-digit number, and then the remaining last 6-digit number. Now let us examine each component. The first character is F. So this is called the application identifier. The value F tells us that a message is being processed through the SWIFT FIN application. SWIFT FIN is the traditional store and forward messaging service used for exchanging empty messages. It does not describe the customer payment itself. Okay. Next, 01. So these two characters basically represent or indicate the service identifier. The value 01 identifies a normal FIN user-to-user financial message. In simple language, it tells the SWIFT network what type of FIN service is being used for the message. This is also network level information. It does not tell us anything about a debtor, creditor, amount, currency, or settlement arrangement. Next comes the logical terminal address. Then this 12 characters basically represent the logical terminal address, or also known as LT address. The logical terminal address identifies the institution and a particular logical terminal through which the message is sent or received. So this is the most important part of block 1 from an ISO 20022 mapping perspective, because it contains the identity of the financial institution. The next 4-digit 1, 2, 3, 4 is the session number. So the session number identifies the FIN session during which the message was transmitted. A SWIFT interface establishes sessions with a SWIFT network. Messages sent during that connection are associated with a particular session number. This helps the FIN infrastructure manage message transmission, sequencing, acknowledgements, recovery, and technical control. However, it does not form part of the business payment information. The final 6 digits are the sequence number, sometimes also referred to as the input sequence number when block 1 belongs to an input message. It identifies the position of that message within the SWIFT FIN session. For example, this could mean that the message is 567,898 messages associated with that particular session sequence. The session number and sequence number together help the SWIFT FIN network uniquely manage the messages from technical transmission perspective. But these numbers are not normally transferred to the pacs.008 business message. So therefore, block 1 follows this particular fixed format. It has a application identifier, then service identifier, then 12 character logical terminal address, then 4-digit session number, and at last it's a 6-digit sequence number. Hope you are now able to understand that block 1 is a technical SWIFT FIN header. It controls how the message is identified and processed by the network. Okay, now this particular slide presents the most important principle that we need to remember throughout the mapping exercise. On the left hand side, we have MT103 Block 1, and Block 1 is a technical FIN header. It basically contains the sender's logical terminal address, the SWIFT application identifier, the service identifier, the session number, the sequence number, which we have seen in the previous slide. On the ISO 2002 side, we have two broad sections. One is app header and the other one is the document. So these two sections have different purposes. The app header is the ISO 20022 business application header. It carries high level information about the business message, such as who is sending the business message, who is receiving the business message identifier, the message definition identifier, the message creation date and time, the business service when applicable. Okay. Mostly it uses this kind of notations. FR stands for from, TO stands for to, message definition identifier, business message identifier. Coming to document part, the document contains the actual payment instruction. It includes business and payment information such as your debtor information, debtor agent information, creditor information, amount, settlement, instruction amount, interbank settlement amount, settlement method, payment identifier, charge information, remittance information, so on. Therefore, document is where this particular block is where the actual customer credit transfer is described. Now, MT103 Block 1 primarily relates to the ISO 20022 header or transport context. It does not map completely into the document part. This means we should not search for fields such as FIN session number or sequence number inside the pacs.008 payment details. Those values belonging to the SWIFT FIN technical environment are generally not business data required by the ISO 20022 payment message. Only the institution identity contained in the logical terminal address has a meaningful relationship with the sender information in the business application header. Let us now examine each block 1 component and its ISO 20022 mapping. The first component is application header. Its meaning is that message uses the SWIFT FIN application. Now this is not mapped to the ISO 20022 format. Why it is not mapped? Because the application identifier belongs specifically to the SWIFT FIN messaging environment. When the target message is created as an ISO 2022 XML message, it is no longer necessary to insert a value inside the pacs.008 saying that the original message used FIN. The messaging channel, protocol, or transport platform may store this information separately, but it is not. But this particular value is not a pacs.008 business element. The next component is service identifier. This identifies the normal FIN financial message service. This is also not mapped to ISO 20022 pacs.008 format. This is because it is network service information specific to the FIN environment. The target ISO 2022 infrastructure will have its own transport rules, service identifiers, envelopes, or network metadata. Therefore, this value is not copied into the pacs.008 document or into the normal business application header field. Next component is the logical terminal address. It has a, the ISO 2022 mapping shown here is derive big for application header / from. So this is the only block 1 component with a meaningful business header relationship. The logical terminal address identifies the sending institution and its technical terminal. From this value, we can derive the sender's big. That is from logical terminal address value, we can derive the sender's big. That big may then be placed in the app header block in the pacs.008 format. Now in this case, word derive is very, very important, because we are not copying the full 12 character logical terminal address directly into this block. We first remove the logical terminal character and construct the 11 character big. The next component is session number. It is not mapped to ISO 20022 format. The session number is used by FIN network to manage the technical messaging session. ISO 20022 does not provide a pacs.008 business field for carrying a FIN session number. A bank may preserve the session number in internal audit records, migration logs, original message archives, technical trace tables, reconciliation databases, and so on. The final component is the sequence number. It is also not mapped in ISO 20022 format. This sequence number belongs to the FIN message transmission control. ISO 20022 uses other identifiers such as business message identifier, message identification, instruction identification, end-to-end identification, transaction identification, UETR, and so on. But none of this should automatically be populated in the with the FIN sequence number. So they have a separate business meanings and separate generation rules. Okay, now this slide explains the most important transformation in mapping. There's a logical terminal address. The logical terminal address looks like this as in our example. This is a 12 character value. This contains 12 characters, and it must not be confused with a standard 11 character big. Let us divide the value. So when we divide the value, we have first 8 characters here. So the first 8 characters are basically the first 8 characters contain the institution code, the country code, and the location code. Out of this, in this 8 character code, the first 4 character basically gives you the institution code. The next 2 characters gives you the country code, and the last 2 characters gives you the location code. The 9 character, which is A here, is the logical terminal code, also known as LT code. It identifies a particular logical terminal associated with the institution's FIN setup. This character is part of the 12 character FIN logical terminal address, but it's not part of the 11 character big. That is why this value must be removed when constructing the big for use in the ISO 20022 format. Now final 3 characters, this represent the branch code. XXX basically represent the primary office or the head office, and for any branches it might represent some numerical values. For other than XXX, a different 3 character country code, different 3 character code at the end may identify a specific branch, department, or operational unit. The original logical terminal address, as you can see from the screen, is this. To derive the big, we remove this logical terminal code, and we use this derived big in the PACS in the ISO 20022 format. Now, why we cannot copy all the 12 characters into ISO 20022? So ISO 20022 expect a valid financial institution identifier code. The 12 character logical terminal address contains an additional technical terminal character. Therefore, if we place this 12 character country code inside the big block, that would be incorrect, because it is not a valid 11 character big. So while transforming, while migrating from MT103 to pacs.008, the transformation rule of removing the 9th character from this logical terminal to get the big is a very, very important. So after deriving the big, we need to understand why it appears in the ISO 20022. So it is placed inside the business application header. Inside the business application header, we have this tag called FR. FR basically stands for from. Now, this business application header, it provides information that applies to the entire business message. FR basically stands for from. It identifies the party that is sending the ISO 20022 business message. Then FIID means the financial institution identification. It indicates that the sender is being identified as a financial institution. Then we have fin institution ID. This means financial institution identification details. It acts as the container for identifiers such as BIC or clearing member identification. Then the final block is a BIC. This is BICFI. This contains a BIC of the financial institution. In plain language, to explain this XML format, it says the ISO 20022 business message is being sent by the financial institution identified by this BIC. Um, in many payment flows, the app header, the application header, sender, and the instructing agent may be the same institution. However, they represent different concepts and should not be treated automatically interchangeable without checking the applicable market practice. Now let us summarize the complete mapping visually. So this gives us the final summary of how MT103 block 1 is treated during mapping to pacs.008. The value F identifies the SWIFT FIN application, and 01 identifies the FIN service. Both are technical network values, so they do not have a direct pacs.008 mapping. The logical terminal address, which is this in the current example, is a key value. We remove the logical terminal A here, which is the 9 character, and derive the BIC. And derive this BIC, which can be used in the ISO 20022 business application header under the sender block or app header /from/big FI. The session number 1, 2, 3 and the sequence number are also FIN specific technical values, so they are not mapped to pacs.008 message. The safest conclusion is that block 1 mainly relates to ISO 20022 header or transport context, not to the payment details inside the pacs.008 document. And this brings us to the end of our discussion on the mapping of MT103 block 1 to ISO 20022 pacs.008. In the next session, we will examine MT103 block 2, which is also known as the application header block. Block 2, let me just give you a context. Block 2 provides additional information about message direction, message type, receiver or sender details, priority and delivery monitoring. We will understand how those values relate to the ISO 20022 message environment. Till then, thank you for watching. See you in the next video.